Now we'll talk about window dependent setup. So this is code you have to run once at the start of the app, and then anytime anything about the window changes, you have to run it again. For example, DPI or the resolution or the orientation, aspect ratio changes, you have to run that again. So let's take a look at the code. So this is the function that we'll talk about, but there is a call in the middle to a really long function that's going to take a while to talk about. So I'll just go into the most important bits in this video. We can always fill in the blanks later. So this function is called do window dependent setup. First thing we do is, if we are a phone app, then we set the swap chain to null. Whether it's the first time we've run this or subsequent times, we just reset that swap chain to force us to recreate it. If it's not a phone app, then we won't do that. For the second time through, we'll just do a resize of the buffers. But for a phone, we want to recreate the swap chain every time. We'll talk about rotation some other time. This is just making sure that we don't proceed if the output size that we've been given, either X or Y, is 0, then we just return immediately, because we're gonna get called again anyway with the correct sizes. And it says in raw pixels because that just means physical pixels. We'll talk about device independent pixels, which depend on the dots per inch, some other time. A bit more orientation code that we'll come back to another time. This is I'll drill into this function in a moment. We'll spend most of our time in this video talking about what's in there, but once you've come out of there, you've got your swap chain created, and then this bit down here only applies if you're integrating with XAML. So it's a Windows runtime app that's integrating with XAML, in which case you actually draw your output to a thing called a swap chain panel that's in your XAML, rather than it going out directly to a window. And so this is just boilerplate code that associates the swap chain you just made with the swap chain panel that's in your XAML. So now let's go into this function. I'll hit F12, we'll go into that function, create swap chain. So there's all kinds of goodness in here that we can talk about. So that first condition there, that's going to be null if this is the first time through, and it's also going to be null on a phone if it's the second or subsequent times through. And all that means is we're just going to go and make a brand new swap chain first. So we got a preprocessor condition here that says if it's max frame rate, we want to set up our swap chain description in a particular way. So max frame rate, if you're running a Windows 32, a Win32 app, if you're compiling this source file in a Win32 app, and you set max frame rate, then that will have the effect of just basically running as fast as you can. It'll just run it'll just present frames as quickly as it possibly can. So this is a Win32 app that's taking around about half a millisecond, not half a second, but half a millisecond per frame. So you're getting 14. This'll go up to about 1700 frames a second as it warms up. But you can only do that with a Win32 app. If you're doing a Windows runtime app, every time you call present, you get held up so that you get a absolute maximum of 60 frames a second, and that really does help with power consumption. You really don't want to be burning out 1600 frames a second when you can really only see 60. So we don't have to go into all these details. That's just what you have to set up, set the description up, swap chain description up for if you want maximum frame rate. If you don't want maximum frame rate, then set it up with just slightly different values. Also notice this is a swap chain desk 1, and that's a swap chain desk, so it's a simpler, kind of older version of that structure. Now just a series of calls of query interfaces really. we take our D3D device and we get a DXG device from it. Then we get the adapter for that DXGI device, and then we get a DXGI factory for that adapter, and we only be using that factory to actually make our swap chain. So now here's an interesting series of conditions. If we're a desktop app, this chunk here applies if we're a desktop app. In this case, it's the same as a Win32 app. If we're a Win32 app and we want maximum frame rate, then we call this really old function that's been around for ages called create swap chain. If we're a Win32 app but we don't want maximum frame rate, then we create swap chain. We call create swap chain for hwind, and we give it the hwind that we've got. And if it's not a Win32 app, then we'll go into this chunk here. So it's a Windows Store app, or a Windows Phone Store app, Win32 app in other words. If we're integrating with XAML, then we call create swap chain for composition. And composition means direct composition, or decomp, and that's just because the swap chain panel is composed using decomp with the rest of the XAML scene. So that's why you have to call that one when you're integrating with XAML in a hybrid app. If you're not integrating with XAML, it's just a regular old Windows runtime app, then you create swap chain for core window. Core window is of course the Windows runtime concept of a window. Set maximum frame latency to 1. That actually doesn't have any effect on the 60 frames per second thing I was talking about. You have to set that anyway. But in a Windows, like I say, with a Windows runtime app, there's nothing you can do. You're pegged at 60 frames a second, which is fine because you just don't want to be burning any more battery power on a mobile device than that. And on a desktop device, it doesn't make any difference anyway. You probably can't see faster than 60 frames a second. But of course, the reason I have this in here is just partly for fun and partly just to see how fast I can get a Win32 scene rendering. So we talked about that. Let's go back up here. So so if the swap chain was null, we went in and we did all that bit to create a new one. If it wasn't, we came in here, and in fact, if it wasn't, this is where we end up. Yeah, okay. So now the swap chain isn't null, so we're just going to resize it. So we basically reset a bunch of stuff that we would have created the first time through this method. We reset it, everything apart from the swap chain essentially. And then we resize the buffers of the swap chain in line with this new size that we've been given. This is an interesting bit. And if resizing gave us one of these two errors, then essentially the device was lost. So we call device lost, which ends up setting up the window independent stuff, setting the DPI, and then calling the function we were just in. So we end up coming back into this function, creating the swap chain correctly, and then that'll drop through and return. So this is the end of that condition of the else part of if the swap chain was null. So if the swap chain was null, we do that bit. If it wasn't null, we do that bit, and then we drop through. So either way, we end up, whether it's the first or the subsequent run through this function, we end up here at some point, having created or resized that swap chain. And there's a few more bits of housekeeping to do from here down to the end of this function. So we'll come back to rotation some other time because it's not that important. Rotation, integrating with XAML. This is just something you have to do for a XAML app. When the DPI changes, you have to mess about with the way that you scale the swap chain panel. We'll probably talk about that some other time as well. It's kind of edge case in some ways. Now we ask the swap chain for its buffer, actually its back buffer, and we store that in this smart pointer. So the back buffer is thought of as a resource because it is a texture, and we're going to be, the reason we want to grab that buffer off of the swap chain is because we need to attach it to the pipeline so that the stuff we render ends up getting into the swap chain and then ultimately onto the screen. Now, so I just said this back buffer is a resource, and the way in general that you attach a resource to the pipeline is through a thing called a view. So resources get attached to the pipeline through a view. Now this buffer is what's called a render target. It's the target of the stuff that we render. So essentially we're making a render target view. So we pass in the buffer that we got off the swap chain, and we get back this smart pointer, this interface that represents that render target view, and we will then subsequently attach that to the pipeline in a minute, as you'll see. Meantime, we have to think about depth stencil. So this is essentially a buffer that gives us depth information. So it's a depth and a stencil buffer combined. So first of all, we describe this depth stencil buffer that we want, and then we ask the device to make a texture, which is again another resource. And remember, we have to attach resources to the pipeline through a view, so we make a depth stencil view. Meanwhile, we make a viewport description. We want the entire buffer to be, the viewport, and then we attach that viewport description to the pipeline. We call RS set viewports. RS is rasterizer stage, which is a late stage in the pipeline. We just pass that in. And then here we're just getting a raw pointer to that render target view and passing it into this API called OM set render targets. And we're doing two things here at the same time. We're passing two resource views in. The first resource view is the render target view, which is pointing at the buffer that we got off of the swap chain, and then the second one is that view into the depth stencil buffer that we made. This is called OM set render targets because OM is the output merger stage of the pipeline. It's the last, pretty much the end of the pipeline. This next bit here is D3D. So first of all we describe the bitmap, the pixel format of the buffer that we're going to be drawing the 2D stuff onto, and then we ask the swap chain for a buffer again, but this time it's the DXGI version of the buffer. Then we make a bitmap from that DXGI we make a bitmap from the D3D context that we created earlier. We pass in the back buffer we just made and the properties that we just made, and we get back a target bitmap. And this is kind of similar in concept to the OM set render targets, where we were kind of attaching those views, those resource views, to the pipeline. In a sense, we're doing a similar thing. We're attaching this 2D bitmap or buffer, whatever, to the D3D mechanism. It's not really a pipeline, but it looks a similar kind of thing. Setting the text anti-alias mode, because we'll be drawing 2D text onto the screen. And this, I'll cover that in a later video, because that's more to do with setting up the perspective that we'll use to actually render the 3D stuff. At this stage in these videos, we haven't even got into 3D stuff really. We're just really setting up the hardware and making ourselves 2D buffers ready for everything to get presented onto. But we'll go on to the 3D stuff and all the fun stuff and the gaming stuff in later videos. And just casting the device into a debugger interface there at the end. So that covers all of the kind of setup, basically all the kind of boilerplate boring stuff you have to get out of the way. So from now on we can start looking into some of the more fun stuff in later videos.